Hello, I am Carson Winter, and this is going to be my video for the second project in Fluids. So to start off with, we're going to go ahead and grab the Fluid Flow Fluent, and we're going to go right into the geometry here. You click on it once, bring that to 2D, and then right-click, and then go into Design Modeler. And we're going to give it a second here to load up. We're going to go boom, bring up our XY plane. And we're going to be doing the 90-degree vertical for the rectangle here. So I'm going to go ahead and use the rectangle by 3 points. Select the middle, go over. Oh, actually, I'm going to zoom in, change my units to centimeters, and then rectangle by 3 points. Click, click, click. That was not straight, but it made it straight. We're going to go to Dimensions, General, click this, and it's going to be 1/2 centimeter, and then zoom in a bit, click on that one, and that's going to be 30 centimeters is what was given to us in the thing, in what he gave us. And then I'm going to zoom out, and I'm going to make it one more rectangle, and that's going to be the box that the airflow moves through. Rectangle. That did not go how I wanted it to go, so we're going to click, 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 and we'll go ahead and go back to Dimensions, General. I'm going to go 500 centimeters by 500 centimeters. Make sure we have plenty of space in here for all the activities that need to go on. And then I'm going to center the box around it by getting the length and distance tool, clicking on the y-axis and the box, click, and put that to 250 centimeters. I'm going to do the same thing again from the x-axis for the vertical and 250. And there you go, you can see the box is squared around there. And then I'm going to go to Concepts, Surfaces, click on Sketch 1, and then Apply, and then press Generate. So if you see this, you got your box here. You're going to zoom in, you can see there's a little cutout there for your bar. So that's all we need to do here. You can go ahead and close this. And then we're going to go into the mesh. We're going to hit Edit. Give it a second here. While it loads up. It's going to take too much longer here. Alright, so there we are. We're going to start by generating the mesh. Just go ahead and hit Generate. And it generated here. We're going to go ahead and hit the inflate tool, where that's at, right here, inflation. So it's going to select that. We're going to apply it for the scoping, that face, and then you're going to go up to edge select here and select your edges that are in the cutout here. Might help zoom in a little bit. There you go. So you have your edges. You're going to come here and hit apply. And you're going to keep it on smooth transition and put your maximum layers up to about 4 or 5. And then you can hit generate again. And we're going to go in and add the names to all our edges here now. So that bottom one I'm going to put as bottom wall, or lower wall. We'll go with lower wall. And then that'll be the front wall on the head. Up here, and the rear wall, and the upper wall. Zoom out, that's going to be your inlet on the left, and on the right is your outlet. And the top and bottom you're going to do SYM, because it's going to be your symmetrical, and that way it doesn't think it's a wall when you go and do your resolutions there. Not resolutions. Your flows there. So you got that. You have your name sections. You can go in here again. You're going to do face meshing. Click on the face, apply. We're going to change it from quadrilaterals to triangles. And that should be good there. And hit generate. What happened here? Why is that an X? That definitely didn't work. Oh, I forgot to change sizing. Capture curvature. Oh no, mesh defacing. No. And you're gonna hit generate again. But why did that stop working? It's not throwing up any errors. Hang on. Give me one moment here. Okay, I'm going to delete that and do it again. So mesh generate. Make sure I have my sizing right. Okay, I didn't change anything else there. So we're going to go into, click on the mesh, inflation, click on that, apply, and then go to edge select here, go down, boom, 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 and you have 4 edges there. Should hit generate. All right, and then you go to the mesh again, go to face meshing, click on the face here, hit apply. Why does it kill the inflation? Give me 1 second here. All right, I figured out what I did wrong here. Sorry about that. I clicked on the wrong thing. So instead of the face meshing, which I clicked before, we're going to go into method. That's what I did wrong. So you're going to select that geometry there. Do that. You're going to do triangles for your domain. And we hit generate again. And when you click on that, you can see that it's triangles, and then in the middle here, where the vertical wall is your rectangles. So after that, we're going to do sizing. We're going to select the edge select tool and do the inside here. Like that, and the top there. We're going to hit apply. Element size we're going to do as 0.1 centimeter. And then we're going to hit generate again, and you can see when the mesh loads how much more detail there is going to be around that. And then we're going to do one more sizing here, and it's going to be the outside edges, your inlet and your outlet. And you can go ahead and put those down to about 10 centimeters there. Oh, and I forgot with this, we're going to turn the capture curvature to no, and then behavior from soft to hard. And then same thing with this one here. You can do that, so no, and then soft to hard. And that one is good. So we're going to go ahead and generate our mesh. And now that it's generated, you can see that there's a lot more going on here, and will be able to help us out. But you still have your slit there, which is going to be the the flow for the flow. So we can go ahead and close this. That's everything we need there. You can go ahead and update. And we're going to go ahead into setup here in a second once that opens up. In a second. It is deciding it wants to chug right now. Alright, so we can go into the setup here, get a nice little double click. We're going to go do double precision. And with the student version, you can only go up to 4 solver processes there. So you're limited by the software or your hardware if that's a limiting factor for you. We're going to give it a second to load in here, everything. And you can see you have your inlet, your outlet, and everything in between. So we're going to go into the models here. We're going to go from viscous SSK omega to K epsilon and enhanced wall treatment with pressure gradient effects. Everything else there is good. You can go ahead and hit OK. Close that one up. We're going to go into our materials, fluid, air. And for that, we were given a density of 1.2 kilograms per meter cubed and a viscosity of 1.8 times 10 to the negative 6. So you can hit change and close. For the cell conditions, I believe we're fine on that. You just want to double check, make sure that material is going to be air there, which it is. So you can go ahead and close that. Boundary conditions for the inlet, we do have a velocity for that of 15 meters a second. That was given to us once again. So we're going to go ahead and apply and close. Close that up. Everything else should be good here. For symmetry, you want to make sure those show up. And then we're going to go into the the reference values. Sorry. Just make sure that you're computing from the inlet, which make sure your values are right. And we're going to change the area and the depth to 0.3 meters. Or my bad, the length is 0.3 meters. And everything else should be right there, and your reference zone is going to be the surface body. Reference frames, there should be nothing to go on there. And then the rest of these should be good. Oh, and reports. I think we can go double click that. No. Give me one second, I'll find it in a minute. And that should be, reference values. No, I did that. I think we're good to initialize here. Go ahead and initialize it. It's been initialized, and then we can run calculations. I'm going to put in about 1,500 calculations or iterations there, and we're going to go ahead and calculate. It shouldn't take too long, maybe a minute or so here for it to run through. I think I did something wrong. Yeah, that's not looking right. I definitely missed a step. I'm going to go ahead and stop that. What did I miss? Walls, that's right. Symmetry, outlet. K epsilon, 2 equations, standard, enhance. Oh, it was turning out right. It was just... Okay, maybe it was fine. I think I just need to add... I'm missing one thing on here, and I can't remember what it is for the life of me. Give me one second, I'll be right back. All right, I found it here. We're going to go ahead and change the residuals to 1e to the negative 6 for all of these here. And okay, I think, oh, that's what I forgot. It was up here. Solutions, residuals, yeah. Okay, that should run fine now. So we're going to go ahead and initialize and calculate. And give it a second here, because it seems to want to be difficult right now. I'm going to go ahead and pause it again while it runs. All right, and here we are. The residuals, or not the residuals, but it's finished integrating here, iterating here. So we're going to go ahead and open up the post, and we got some new data here. Give it a second to upload. I think it's done. Yeah. So we're going to go add a pressure contour map here. Pressure contour. And location's going to be 1 pressure gradient global and 110 contours. Go ahead and hit apply. And you can see the pressure contour here. We're going to go ahead and fix up that legend because it's a little ugly looking. I'm going to put it to just the variable, and from scientific to fixed, and everything else should be good here in between. So yeah, as you can see here, you can see how the pressure gradient and pressure builds up along the flat plate there. Next, we're going to add in, we're going to unselect the pressure contour. We're going to add in a velocity contour. And we're going to select velocity, symmetry 1, and 110 contours, hit apply. And you can see how the velocity is, the low velocity area, super low velocity area, and the high velocity areas here. With that, we're going to turn that off again here one more time, and we're going to do our vector contour map. Hit OK. Go to locations as symmetry 1, and everything else can remain. And you can see how the velocity moves around as you get closer into that flat plate there, and how it turns into a low velocity area right behind it, and the velocity peaks around the board there. And with that, we have all of everything we need here. If we go back into Fluent, the solutions there, go down to reports, forces, you're going to select all of those and print. And it gives you the pressure, the viscous, and the total forces that are felt along each section of that wall within there. So that's everything here, as we only had to do one case today, and I showed off the 90-degree vertical case there for y'all. Yeah, bye.